Hello guys, today we are going to learn some ways in which we can differentiate or distinguish which is an aldehyde and which is a ketone. Now there are two ways of doing this. Number one, the Fehling solution test, and number two, the Tollen's reagent test. Before we move on further, we also need to know this very important point, which is aldehydes are better reducing agents than ketones. That is, aldehydes get themselves oxidized more easily than ketones. We know that reducing agents are those reactants that reduce the other reactant and oxidize themselves, and oxidizing agents are those reactants that oxidize the other reactant and reduce themselves. So aldehydes, they oxidize themselves more easily or reduce the other reactant more easily than ketones. So first we are going to learn about the Fehling solution test. The main observation in this test is that aldehydes will give a red precipitate when added to Fehling solution, and ketones will have no reaction at all when added to Fehling solution. Now you guys might have a question, what is Fehling solution? So, first of all, the fading solution is clear royal blue in color. Now, for advanced subsidiary levels or A levels, for A level students, you only need to know this much about fading solution, which is it is an alkaline solution of a complex compound of copper 2 ions, or more specifically, the copper 2 ions are held as a complex ion. The copper 2 ions are held as a complex ion in an alkaline solution of copper 2 tartrate, which is known as the Fehling solution, and the alkali that is used is mainly sodium hydroxide. So as we can see, if we add Fehling solution and any ketone in a test tube, there will be no reaction between them. But if we add an aldehyde, any aldehyde and a Fehling solution in a test tube, we will see a red precipitate which is of copper 1 oxide. And here in this reaction between the aldehyde and the Fehling solution, the aldehyde gets oxidized itself, or it reduces the Fehling solution. And we have known earlier that aldehydes are good reducing agents, or in other words, they get oxidized easily. Now when aldehydes get oxidized, we get a carboxylic acid. Now here is a representation of how the reaction between an aldehyde and Fehling solution goes. So here this is the aldehyde. Here R represents unimportant alkyl groups or carbon chain. R is that part of the aldehyde which does not take part in this reaction. So it is completely unimportant in this reaction mechanism. So we represent that part of the aldehyde or that carbon chain, which can be an alkyl, methyl, any carbon chain length. We represent that with an R. So aldehyde plus a Fehling solution, we know that the aldehyde gets oxidized, and when aldehydes get oxidized, they form carboxylic acids. So as you can see, the aldehyde functional group here has changed into a carboxylic acid functional group, and extra oxygen has been added, and we know that when an oxygen is added to a compound, it gets oxidized. But that is not the end of the reaction. Fehling solution, as we know, is an alkaline solution of complex copper 2 ions, containing complex copper 2 ions, and the alkali that is normally used is sodium hydroxide. And we know that any metal hydroxide plus any kind of an acid will form a salt plus water. So the carboxylic acid formed will instantly react with the alkali of the Fehling solution to form a salt plus water. Now we know that aldehydes are good reducing agents, which means they reduce the other reactant. In this case, they will reduce the Fehling solution. The Fehling solution contains copper plus 2 ions. So at the end of the reaction, we get copper 1 oxide. So it contains the Cu plus 1 ion. So we can see that the oxidation state of copper 2 has decreased from plus 2 to plus 1 to form copper 1 ion. So we can say that the copper 2 ions have been reduced to copper 1 ions, and they have formed copper 1 oxide. So the copper gets reduced. This proves that aldehyde is a good reducing agent, and this copper 1 oxide is found in solid form and its color is red. So we get this red precipitate, and that is the main observation which proves that in this reaction an aldehyde was present. And if the reaction does not occur, then we know that the other reactant was a ketone. With aldehydes, the clear royal blue color of Fehling solution will turn to a red precipitate. Now, next we will learn about the Tollen's reagent test. This test This test also uses the fact that aldehydes are better reducing agents than ketones, or aldehydes get oxidized easily than ketones. It is also called the silver mirror test. So, what is Tollen's reagent? In simple words, it is an ammoniacal solution of silver hydroxide or silver nitrate. So now we will look at how the Tollen's reagent is prepared. First, we will look how the ammoniacal solution of silver hydroxide is prepared. It is prepared using this following reaction. First, aqueous silver nitrate and aqueous sodium hydroxide are reacted, and they go through a double displacement or a precipitation reaction to form sodium nitrate and silver hydroxide. Here, the sodium displaces the silver to form sodium nitrate, and the silver goes and reacts with the hydroxide ion to form the silver hydroxide. This is because sodium is more reactive than silver, or higher up in the reactivity series than silver, therefore it can displace silver. Now, sodium nitrate is soluble, so it will form an aqueous colorless solution. But silver hydroxide, it is insoluble, so it will be seen in a solid form in the reaction mixture, and so therefore it will be seen as a white precipitate. Now, after we add aqueous ammonia to this mixture, we are going to get a complex compound which is the ammoniacal solution of silver hydroxide. And here, the white precipitate of silver hydroxide, it will dissolve to form a solution of this compound which is called the ammoniacal silver hydroxide. Now this is the reaction by which we can prepare the ammoniacal silver nitrate, which is another type of the Tollen's reagent. Now this reaction will not be needed in your A-level curriculum, but it is good to know that. In future, if you pursue chemistry as in your higher studies, then you might require this equation, so it is good to know it. Now, the trend with Tollen's reagent is pretty much the same. When reacting with ketones, there will be no reaction, but when Tollen's reagent is added to an aldehyde, a reaction will occur and the aldehyde will get oxidized like it did with Fehling solution. Here is a reaction mechanism for aldehydes reacting with Tollen's reagent. Again, the R represents that part of the aldehyde which is not taking place in this reaction. So here is the aldehyde functional group reacting with the Tollen's reagent. So again, the aldehyde gets oxidized to form a carboxylic acid. So here we can see the carboxylic acid group. Now, that is again not the end of the reaction. The carboxylic acid then reacts further with this part of the ammoniacal solution of silver hydroxide. This part is an alkaline. As we know, ammonia is an alkaline compound. So this part of the Tollen's reagent, it is alkaline. So it reacts further with this alkaline part to form an ammonium salt plus solid silver, water and ammonia. Now as we know, aldehydes are good reducing agents, so which means the Tollen's reagent will get reduced. So in the Tollen's reagent, the silver has an oxidation state of +1, but at the end of the reaction we can see that in solid silver in elemental form it has an oxidation state of 0. So from +1 it has gone down to 0, so silver has been reduced. So this proves that aldehyde again acting as a good reducing agent and therefore oxidizing itself. Now, the ammonium salt formed is colorless. So what will be our observation? In the test tube, we will see just a colorless solution. So how can we know that a reaction has taken place and it is an aldehyde? The answer lies in here. Solid silver or elemental silver. You know its color, it's silver. So the observation is that a thin film of silver will be deposited on the inner wall of the glass test tube, which will look like a mirror. So if this is the test tube, on the inner wall, that solid silver will be deposited. And therefore, when looking from outside, it will look like a mirror, and that will prove that an aldehyde was present. Now, this test requires a lot of precision, and many first timers do not get that perfect mirror that they were expecting to. So, as a result, don't get worried. At the end of the reaction, if there is an aldehyde present and you don't get that mirror, you will still see black precipitates of solid silver after some time. That will also prove that an aldehyde is present. And on the other hand, with ketones, there will be no reaction and the solution will stay as it was, colorless. Thank you for watching this video, and if you have liked it or found it useful, then please don't forget to subscribe and like my video and share it with your friends. Thank you. Goodbye.